Okay, so our third speaker today is Samantha, and if you please welcome her to the stage. And she's going to talk about robots and testing. Thank you.
Can you hear me without the remote, without the microphone out the back there? Or should I be using the microphone? Okay, I'll use the microphone. My name's Sam. I'm a tester here at Tyro, or I was a tester until I left 2 weeks ago. I'm in between jobs at the moment, and I start a new job at Google in a week. So I feel like this conference kind of talks to me now. But yeah, I feel a little bit out of the ordinary, a tester at a developer conference. I guess we're like your evil twin. We always point out the flaws in your hard-earned work. Unfortunately, but I can also have a bit of fun with testing as well. So this is a robot that's an open source project that you can use for testing. Helps if I switch things on properly. We've named this robot Tappy McTapface. There was a competition here at Tyro to name it during a hackathon. So I'm actually going to jump straight into the demo first and then talk about the robot afterwards. So here we go. Demo time. Let's hope the demo gods smile nicely upon me. So I am going to also set it up on the screen for you to see more so. There we go. You're all on TV now. And if I go over to my terminal and I run my Node Play Piano, I'm running a Node server. There we go. And if I play a song like Merry Christmas, there we go. Let's... There we go. And just some more music here. Oops. We have some timing issues with that robot at the moment, but hopefully you could recognize the song. Now back to my slides. Where are we? There we go. So this is a robot that you can use to test mobile apps. It's an open source project. You can access the repository here with all of the 3D files as well. Based on version 2, also created by this guy, Jason Huggins, who was one of the founders of the Selenium framework as well. So I think he just wanted to, that's like an earlier prototype version where you could use it to interact on a tablet. And I think that demo version, he was using it to play Angry Birds. All the parts, the green parts and whatnot are 3D printable. I printed them here in the office. We got a 3D printer a couple of weeks ago to give out at YAL next week, and I was able to get some parts printed. They use Bitbeam, which is a Lego compatible pieces. When they say Lego compatible, they don't really mean Lego compatible. It doesn't actually work. I tested it. They're just roughly the same size, but they don't click very well. They're very similar to the Lego Technic pieces. They're also not as durable as Lego pieces, I guess because as you print it, you tend to optimize for build times rather than having solid plastic as well. It took about 20 hours worth of printing for all of those green parts, so it wasn't a quick thing to do. I also screwed up my first print. This was the results of the first print. It went a little bit haywire. Note to self, do not put prints near the edge of the printer. Learned that one the hard way. All of the larger parts I could have printed, but I actually got them laser cut at a hackerspace, Robots and Dinosaurs in Meadowbank. If you've ever been inclined to check out a hackerspace, I quite like that one. There's an Arduino board and it's connected to 3 servo motors, and those the rotation gets translated into XYZ coordinates on the phone plane. We also use magnets and ball bearings for joints. Oh, there we go. I would pass them around if you want to have a look. I might need them back at some point. This way, not this way, this way. Yeah, there we go. It took actually about 2 days to build once I had all the parts printed. So I spent a day in the hackerspace assembling a lot of the parts, and then maybe about 2 afternoons as well after work. So it didn't actually take that long to build once I found the instructions. It cost about $300 in parts. I was following the recipe, so I was ordering from American sites, and the postage was a lot more expensive. I think if I had found Australian dealers, it would be a lot cheaper, maybe around the $200, $250 mark. But I've spent more on Lego robots before, so I guess it's not that bad. We also hacked that Play Piano music in about a 1.5 day hackathon. The hackathon was a Christmas-themed one 2 weeks ago here at Taro. So that's why we've got Rudolph with his red nose LED playing in time to the music, because it was a bit of a nice Christmas touch. But to extend the Christmas theme we had this morning. It runs on the Arduino, you run Fermata. Now Fermata is a protocol to control microcontrollers from another computer. So we're actually running the code from our local machine, and there's a protocol that translates it into Arduino code. I'm also running a Node JavaScript server, and you saw the Play Piano was a JavaScript class we have. I have that JavaScript class on my GitHub repository as well, if you want to have a play around with it. Also, we use the Johnny5 API, which is a JavaScript for Internet of Things. It doesn't have the full suite of JavaScript available at your disposal. Oh, I'm losing stuff. There we go. Cool. And this is a fairly new library. It's only been around for a couple of years. But also the Tapster robot, I think, has only been on GitHub for a couple of years as well. So it's all fairly new and experimental, but it was a lot of fun to build. We mapped out our XYZ coordinates of all of our keys. You can see right up the top there we have E4 to represent the E4 key on our keyboard. We have XYZ to map for when it's pressed and when it's lifted, so that when we're moving from key to key, we actually move from lifted position to lifted position before we trigger the press. And that's why there's some timing issues when we're trying to play faster music, such as the Darth Vader music, because we don't quite have the timing right yet. It's playing the quick notes too slowly and the longer notes too quickly, but it's still a bit of a hack. Unfortunately, our keys are hard-coded. Then we also pass in a string that represents music. So that Merry Christmas that we've got 2 D3 there at the start, that means play the D3 note for 2/16ths of a bar. How many of you guys familiar with music, could read sheet music and... Okay. We just tried to programmatically represent music and pass in a string that all we have to do is pass off to the robot, and it knows how to play it because we've mapped out all the XYZ coordinates of all the keys and whatnot. So how can this help you test? I can see at least two main applications. The UI automation on a physical device. One thing I would like to build next is if you had an app running in debug mode, you should be able to read the UI elements via USB. If you had some sort of layer that converted them to XYZ coordinates, then you could translate them to the app. I haven't built that part yet. I don't know how hard it would be, but it doesn't sound that hard, right? But that's what most tech, it always sounds easier than when you actually get to do it. I think also if you wanted to do extended performance testing or load testing on a real device, you could set this up to be clicking the same button over and over and over again for hours at a time. Actually, I noticed with this app, it's a keyboard app, because it's a free app, when we were using it for our testing during the hackathon, we would miss keys a lot of the time, especially if we had it running for like an hour or two. So I found a performance issue in this app, but because it's free, you kind of expect some bugs, I guess. I think someone was telling me one of the ideas they had for this robot, potential applications, is Snapchat doesn't allow you to line up chats. It doesn't allow you to post them at a different time. With this robot, you might be able to do that. You might be able to set it up so you could post your Snapchats at 1 a.m. or 5 a.m. or tweet when you're asleep. Are there any other applications that other people can think of off the top of their head? Sorry, could you please a bit louder? Okay, use some image processing to read sheet music and then palm it off to the robot. Cool. Well, hopefully, it's you're only limited by your imagination. It has some testing applications. I think as our tools progress, though, they tend to get better and more reflective. So anyway, it was a lot of fun to build. My lessons learned while I was building this, it was really hard to find instructions to build. They're a little bit all over the internet. They weren't located in the GitHub repository. So that was interesting, but I did find some instructions. I think I printed a few too many parts, and I think it's because there was a bit of a difference between the build of materials in the GitHub repository and the build instructions. That also meant I ordered too many bolts of one type and not enough, also because of these differences between the build of materials and the instructions that I was following. So all the parts were, because this is an American project, all the nuts and bolts were in inches and threads per inch and measurements that I didn't really understand. So I wanted to try the American nuts and bolts first before trying metric, but then ended up moving towards metric nuts and bolts. So one thing I'd like to do is to create a build of materials for metric system, and also to update the instructions and the build of materials as well. That's basically it in a nutshell. Any questions so far? How about multi-touch? I was actually just thinking that this morning, that at the moment it doesn't support multi-touch. You'd have to rejiggy the design a little bit, because where the stylus is being held at the moment, if you had two styluses right there, they wouldn't be able to really touch close together, so the pinch and zoom might be a bit challenging to do as well. But I guess with a bit of time, you could probably figure something out. At the moment, it's just a single touch.
Is that possible to just take your pen and move on the mobile device screen and record your movement?
Yeah, so the question was, is it possible to move the pen and record the movements? Yeah. With the current JavaScript, it's not, but one of the things I wanted to experiment with was if we disabled the motors, because right now they're locked into position. So if we disabled them and allowed you could record the rotation from each motor as you moved it around. It's possible because I've seen that with like Now robots and whatnot. But in the current source code, it's not supported.
Would it be much easier to do
Yeah.
the testing?
Yeah, it would be much easier to do the testing. One of the things I found with the JavaScript is that it makes debugging hardware a bit easier as well. There was this Go function that allows you to go to XYZ coordinates, and by getting the XYZ coordinates of a couple of keys, you could see the delta or the difference between the keys, and then you could use that to map out all the other coordinates. So that actually wasn't that hard. I thought we would spend a lot more time doing config and calibration. Who would like to come up and have a play? There's another function. If I simplify the keyboard, we've got a play function where you can just pass in a string of characters and it will play it to the music. Give me a second. So, done. No. That way. For example. No. Oh, I'm losing my screen again. Play. So we have C, D, D, E, E, E. So this one here will play C for one note, D for two notes, and E for four notes. Does anyone have any other music that they'd like to play? On this keyboard setup, we also have, I think, Jingle Bells. And I just noticed we're about 17 minutes in, so we've got plenty of time left. Yeah, so the question was, with different phone sizes and screen sizes, how would you calibrate it to know where the keys are? At the moment, it's just hard-coded to my phone. I think if you didn't have access to a debug build, it would be a little bit more challenging. You would either have to set up some sort of camera setup to be able to read the screen and translate them into XYZ coordinates, but I think the easiest way potentially is to read the screen via the USB, get the XYZ coordinates of UI elements, and then translate them to the robot. That hasn't been built yet, but that's where I'd like to see it go. Yes? So the question was, with the iPhone, does it support the pressure touch? Is that the correct the force touch?
Can you specify how much pressure you're actually putting on the screen?
There's no way to read the pressure from the servo motors, but you could. Someone's giving me a phone call. Oh. I'll just get the robot to answer it. If you could map out the Z coordinates based on the amount of pressure, but it would require a bit of trial and error, and it would be hard-coded, be dependent on the length of the stylus you're using as well. So I don't know of a programmatic way to be able to get that with the current setup, because the servo motors, they could probably tell you how far the screen is down, and then you might be able to tweak it with a small delta either side to get a light touch and a force touch. One of the things you could do potentially before you start playing around with the phone is to do a calibration where it just goes around the whole phone and gets the dimensions of the phone. Anything that it presses further is where the edge roughly is. So you could do that programmatically as well to get where the phone is located. There we, in the, sorry. Yeah.
Would everything be compatible if you wanted to port that into a Pi?
If you ported that to a Pi, I can't see why not, because we're just, it really depends how you get JavaScript talking to Pi, but because Johnny 5 already talks to a Raspberry Pi, as well as Arduino, it shouldn't be that hard.
And the second question, is there anything to stop you running Node directly on the Arduino board?
On this Arduino, you can't run Node directly, but there is another Arduino board, or not Arduino board, but there is another board that's kind of in between Arduino and Raspberry Pi that runs JavaScript natively.
Really helpful.
Firstly, awesome talk, congrats. And my question more around June 5 thing, and what's the next step that did you add unit testing that, or thinking improve your code? What do you think about that?
What do I think about Johnny 5 and unit testing and potentially next steps?
For your application?
I would like to see just a translation layer in between running UI tests from a machine to the robot. I think the tools, while we're developing for unit testing, I don't see this replacing that at any point, because I think the tools we've been using for unit testing have developed, they're kind of mature-ish now. The developers on my old team were always of the mantra that unit tests should be quick to build, quick to execute. So if you abstract your code in such a way that you can execute your unit test separate from the UI, then that makes them faster. You could use this for unit testing, but it would be very slow, and I would say because you've got added hardware as well, it's prone to more error over time. I mean, like, we know that UI tests are flaky generally because things are always changing. With a robot, it would introduce even more flakiness and false positives. So I don't actually see it being used for that. Does that help?
Yeah, a lot. Thanks.
One quick question I had, does it kind of support drag and drop? So you can put the pen down and drag it across the surface?
Yeah, so the question was, does it support drag and drop? And yes, it does. With the Angry Birds demo, you can see it do the drop, push, release. We were going to try and get it to unlock the phone as well, because you could press the home button and then enter a pin and whatnot, but we never got that far because this is basically my hack and tell.
Excellent. Well, if there are no more questions, thank you very much, Samantha, for a great talk. Thank you very much.